Okay, so what we want to do particularly in this video is just explaining how to defend those answers that I gave you guys for your assignments. Okay, but you need to actually know some precedents. So that's basically what we need to set up before we now answer those questions. So we are going to talk about compound statements. Now, what is a compound statement? A compound statement is actually a statement that is made up of sub-statements. As you can see, the word actually sells it. That is going to be a statement that involves 1, 2, 3, or even more sub-statements. That's basically what it is. Let me give you an example. Let's say there is a sentence, Billy is a dog. And then there is also another statement, Billy is a friend. Right? So these are two statements. I can combine them and make one statement. That means Billy is a dog and a friend, right? Or I could also say Billy is a dog or a friend. That is a compound statement because I've combined two possible simpler statements into one. So that's basically what a compound statement is. Then let's look at something. Want to look at disjunction. These things are called connectives in logic. So I'm going to start with disjunction. Now, what's a disjunction? Disjunction is actually represented with this symbol. And it's in any case where you see either something happening, then they'll say or something. Okay? So if you hear either so and so or so and so, that is actually a disjuncted statement. Okay? So just hold that at the back. So let me give you now an example. Let's say there is a statement here, Billy is a dog, or Billy is a friend, or Billy is a dog or a friend. Just to make the English to be more palatable, that's the reason why you don't need to repeat saying Billy and Billy. That's just going to be mindless repetition. So that is not actually allowed. It makes the English to sound awkward. But now this is actually a more polished English. Billy is a dog or a friend. Now, where is the disjunction? Where is the connective here? This is a compound statement, as you know, because we could split this statement into two. The disjunction is actually this one that you see here. The or that you see is the disjunction. Okay? Now, even if you wanted to say Billy is either a dog or a friend, you could also say that, but there is actually something called inclusivity and exclusivity. The inclusivity is whether these two things can actually happen. Is it actually completely publicly held that dogs are friends? If that is the case, then you can say Billy is a dog or a friend, or Billy is a dog and a friend. But then there is something called exclusivity. The example I just gave you, that one is an example for inclusivity. If I'm talking about exclusivity, then let's say you talk about this, either Billy is a lion or a dog. Can you say this? Now, where is actually the exclusivity? It's in a situation that you have a lion or a dog being the character or the characteristic of this subject, Billy. And Billy cannot be a lion and a dog at the same time. So for you to have said either Billy is a lion or a dog is completely okay, and this is more palatable. But we might not well say either Billy is a dog or a friend, but we can see that with this. Now, this one is actually something that's called an exclusive statement, because it cannot be those two things at once, right? So this exclusive. This one is actually going to be inclusive, because it's possible that it can be a dog and what? Be a friend. But in this case, we are using or. That or is just exactly the connective for those two stuffs. And that's basically just what I wanted to establish there for you. So anytime you see something is this or that, you're basically talking about that it's or this thing or that thing. Now let me give you an example. Let's say you have P and then you have Q. Okay, Then let's say we combined the statement P and the statement Q with a disjunction connective. So that's going to be a P disjuncted with what? A Q. Let's say the first truth value of the P statement is true, and the second is a true, the third is a false, and the last is also a false. Now, let's say for this one, we have a true, false, true, and another false. Okay. Now, if you have P disjuncted with a Q, the answer is actually supposed to be a truth. That is, a truth disjuncted with a truth is going to be a truth. Truth or a true is going to be a true. True or a false is actually still going to be a true. And a false or a true is going to be a true under disjunction. But false with a false, that gives us a false. That's actually the difference, okay? So the difference between that thing, you should just know it by now already, right? Truth with a false, when they're actually disjuncted, they're going to have what? A true. True or false rather with a true, if they are disjuncted, you are going to have what? A true. The only exception is where you have a false with a false, then the answer is going to be false. So just hold this one at the back. Now let us go to the other one. You need to also know this one, conjunction. Now for conjunctions, that is going to be written this way. This is the symbol of conjunction. And basically I'm talking about and. So if they say this thing is this and this, then the connective in that statement will be a conjunction or conjunctive connective. Let me give you an example. If they say Billy, right? Billy is a dog and a friend. Billy is a dog and a friend. You can see this is a connective. Now we know this could be one statement, and this could be another statement. So we can actually combine it and say if this statement is P and this statement, let's call it a Q, we can actually combine it. So we can say that P is what? Conjuncted with Q. So that's actually how it's written. I'll clean it out. Okay, so let's see how the truth table for conjunction works. So have this. So let this be the first one, statement this, and then let's have P with this one. Now let's say the first one, the first statement of P, let's say it has a truth value of true, and this one the truth value of true also, and here false and false. And then let me change this, alternating false with true, just to be able to have different values for the truth values for Q. Now, if you have Q intersect, now I'm calling it intersection because very, very closely it resembles the intersection you know about in sets. So if you actually remember something like that, there is a little bit of should I say parallelity that it has with sets. Now, truth with the truth obviously gives the truth in both situations, either in disjunction or in conjunction. That is, whether in disjunction or conjunction, it's always going to give a truth. But for this one, you know, in the previous case where we had truth with a false, it actually gave us a truth. But for conjunction, it goes to be a false. This is also going to be a false, therefore. Now, this one is also going to be a false. Now, the reason why that is anytime you have a false with a false, that is actually going to give you a false. There is actually no big deal about that, okay? It's always going to give you a false. Now, but there is then another one that is called implication, which is where I want us to go to now. Implication will almost resemble conjunction, just that at the end it's now going to have the false changing to a truth. So that's going to be implication. That's the next one. Implication, this is the symbol of it. Okay, let me give you an example. It is raining. It is raining so the ground is wet. This is a very good example of implication, right? It is raining, so the ground is what? Wet. Now, where is the implication? This whole part is actually going to be the implication. Now, this is going to be this one. This will be the antecedent. This one. Antecedent, it means what precedes the answer or the product. Okay, so that's basically what it is. Now, what is the symbol or the connective that is actually called an implication? It's actually going to be this part, this particular two-word phrase. So the ground is wet. Okay, so just understand that implies is basically, you could even say it implies as a word. If you see it implies, it's still an example of implication. You could have if. For example, if it is raining, we know that the ground would always be wet. Another one you could have is because, and another one you could even have since. Do you understand? In fact, there might be actually another one where you say, as far as it is raining, the ground will always be what? Wet. So basically, that's what we're talking about. Now, let us look at the truth table for implications. Hopefully, this is going to be enough space. So let's say this is the first statement, then you have another statement. Then let's imply this statement P to Q. So let's say the truth value for the first statement is true, for the second true, false, and the last, let's use a false. Here let's have a truth and a false, a truth with another false. Now if you have truth and truth being implied together, the answer will be a truth. If you have a truth and a false, the same thing that happened in conjunction will happen here. So it's going to change to a false. This is also going to give us a false. But if you have false with a false, then that implies that it's actually going to be a true. If the false of a false statement is there, that means it's going to change to a true, right? So that is actually the stuff under implication. Now take very careful note of all these things because we're actually going to use it to answer those questions. Then the other one is called negation. Okay, negation. Now negation is actually represented with this stuff. I really don't think I know the name of this symbol, but that's actually the symbol that is used to represent negation. So let's say if we say that Billy, right? Billy is a dog. And let's call the name of this statement P. Like these are the letters that you use to represent sentences or statements. So if I actually wanted to negate the sentence P, I would actually use this. Can you see that? So this means that this is the opposite or the converse of it, which is actually going to now be Billy is not a dog, or it is not the case that Billy is a dog. Do you understand? So hopefully you have gotten everything. Now this one is very simple. If I have the truth value of P to be true, the truth value of a negated P will basically just be a false. And so that is actually the easiest part of everything. Now with all this, now we are now going to go to this thing called tautology. I don't know if actually I've told you about it, but tautology is actually a compound statement. Okay, tautology is a compound statement. It is a compound statement that is always going to be true irrespective of the truth values of the sub-statements. Now you already know what sub-statements are, right? If you have a compound statement and it's always going to hold true. Now let me give you an example. Let's create a truth table for P and a negated P. And then let's look at the tautology of it. Let's have P and then let's have a negated P. Now, there is a way that tautology works. If you actually use a disjunction with a tautology, that's where there is actually a tautology. That is either this statement or the other statement. So we are going to have P disjuncted with a P, with a negative P or negated P. So let's say this is true, and let's say this is true, this is false, and let's say this is false. And let's say this is false, this is false, this is true, and this is true. If you don't actually want to represent it this way, whichever way you want to represent it, but just try doing it. Now, if I disjuncted P with a negated P, what's that going to give? Because as you can see, truth with a false in disjunction always gives us a truth. This is also going to be a truth. This will be a truth. This would also be a truth. So as you can see, all the values of disjunction under tautology, they're always going to be true. And it's always under disjunction. That's basically what it is. Then the next one is contradiction. Now, contradiction is the direct opposite of tautology. We said tautology, all the truth values of tautology, they are always going to be what? True. Okay? Whatever the truth value of the sub-statement or the simpler composite statements that combine together to make the compound statement. Now, contradiction, all contradiction is a compound statement which will always hold as false no matter the truth value of the sub-statements that combine to make up that total statement. Now, for that one, you actually use conjunction. So let's do that now. Okay, so let's say this is P and let's negate it with a P. But in this case, we are going to use a conjunction. So this is what you have, and then you have a P right there. So let's use it the same way. This is going to be a true, true, false, and here we're going to have another false. So this should be a false, this should be a false, this is a true, and here this is going to be a true. Now, if you have conjunction, you know this basically is going to turn us toward a false. This would also be a false. This is also going to be a false, and this is also going to be a false. So you can see that contradictions always hold for what? Conjunctions. Tautology always holds for what? Disjunctions. So hopefully I've gotten that. Now let's go to the other question. The other question is that they said, given two propositions P and Q, verify the validity of the argument this. So that's number 1B. They said we should verify this, the validity of this. That's P with this Q, and then you have something like this. We need to verify it. Now, basically what I think they are trying to ask us to do is basically to check whether it's going to be a contradiction or it's going to be a tautology. Now, if you look at it very well, this part should actually now tell us whether it's going to be a tautology or a contradiction. I mean a conjunction. Okay, conjunction, contradiction, same thing. Tautology, disjunction, same thing. So as you can see, the final stuff you have here is actually tautology because there is what? Disjunction here. So basically they are trying to tell you that you should prove that this statement is actually what? A tautology. So let's go there. Now this is the basic thing that I'm going to do. We need to have P, we need to have Q. We need to have P conjuncted with a Q. Then we need to have the negated form of P conjuncted with a Q. And then finally, we'll have to disjunct the answer to a Q. So I'm just going to leave it as an open end. Now, let's start with a P. Then this is a Q. This is going to be a P conjuncted with a Q. Then we'll have a negation of that conjunction. Okay. Then lastly, we'll have this negated conjunction being in disjunction with a Q again, right? So let's say we have truth, truth, false, and a false. Then we have truth, false, truth, false. Okay, so if we have P conjuncted with a Q, truth and truth, it always gives a truth. This one, false and false, it will still give what? A false. But it happens to be that this ones always give false. So this is false. This is also going to be a false. Next up, this stuff means the negation of the previous column. So this column, we are going to change it. So this is going to be a false. This is going to be a true, true, and a true. Then finally, we have this stuff, which is going to be in disjunction with a Q. This is our Q. So if you have a truth and a false, what's going to be the disjunction? Obviously, a truth. This is also going to be a truth. Obviously, T and T gives us a truth. F and T always a. Now, you can see that we have all true values, the values of this the truth values of this stuff is completely true, right? So with that, we are going to conclude and say that this is what? Tautology. That's basically what you need to do. Since the truth values of this are completely true, it means this is a tautology. That's a compound statement. Of course, this is a compound statement, right? A compound statement that leads to be completely true no matter what the values of what the composite, I say composite, the constituent sentences or statements. So that's basically. Now finally we are going to the last question, that is IC, where you are asked that if P is a statement, he is rich. So let's write it out. P, he is rich. And then Q, he is wealthy. So having got this, we are required to rewrite these logical statements as verbal statements. So here is the first one. We are required to write this P in conjunction with a Q. So what does that mean? You know that P in conjunction with a Q, that means he's rich and he's wealthy, right? Because this means and, right? So he's rich and he's wealthy, but there is a negation to that statement. So that means he is not rich and wealthy. That's basically how you might put it. You could also put it in this way. It is not the case that he is rich and wealthy. You get? So these are two ways you can actually put this statement. Hopefully understandable. Now let's go back to the second one. So the second one there, we are required to show this. Well, this should be a negated Q. Now what is a negated Q? For a negated Q, that means this guy is not wealthy, right? But he's what? Rich. Now there is an and here. So the direct verbal change of that's actually supposed to be he is rich and he is not wealthy. That's basically what it is. He is rich and he's not wealthy. You could also say it in the other way. He's rich but not wealthy. You could also say it like that if you want. That's in a more grammatical, palatable English. But remember, it's math we are doing here, so that may not really come into handy. You just want a direct interpretation of what you see there. And the next one we have is P is like this, equal to a Q. Now, I've already talked about this. This is an implication. So what that means is, if he is rich, then he is wealthy. That's basically it. If he is rich, then he is wealthy. Okay? Then he is wealthy. You could have it this way. You could also have it that since he's wealthy, he's rich, right? Since he is wealthy, he is what? He is rich. And you could try doing it in the other way also, as much as possible. Okay, now the last, well, that should be the fourth. The fourth is this, which is actually simple. So I'll leave you to try this one yourself. Now let us try the last one. The last one says P disjuncted with negated Q. Now you already know what a negated Q is. It means he's not wealthy. Now this is he is rich or he's not wealthy. That's the typical explanation from direct view of the mathematical symbol. He is rich and he is not wealthy. So that's basically it. So by now, you should be able to prove and defend all the answers that you have seen for the answers or solutions to those questions that you were asked. So that's basically it.